As one of the oldest and most well-known idioms, "divide and conquer" comes from the Latin term "divide et impera", which translates to "divide and rule". While the idiom has been used for much longer than most, it was first used in the English in 1600s. In real life, we frequently divide things into helpful categories. When sorting change, we separate the coins into their various denominations first, then we sum the values of each denomination before combining them. Consider a teacher who arranges the papers of their pupils according to the first letters of their names. Similar to how a sorting algorithm like the bucket sort works this kind of task, it can cut out a lot of details by focusing solely on the initial letter of the first name. Sorting is more productive thanks to this automated method.
The merge sort uses a recursive algorithm to achieve its results. The divide and conquer algorithm breaks down a big problem into smaller, more manageable pieces that look similar to the initial problem. It then solves these subproblems recursively and puts their solution together to solve the original problem. Simply said, the merge sort procedure involves splitting the array in half, sorting each half, and then joining the sorted halves back together. Up till the full array is sorted, this procedure is repeated.
A real-life example of merge sort could be organizing a deck of playing cards. In order to sort the deck, you would first divide the deck into smaller groups of cards. Then, you would repeatedly compare and merge the smaller group of cards in order to organize them by suit and value. This process follows the same basic steps as the merge sort algorithm used in computer programming. The way merge sort works is that it starts at the top and works its way down, splitting the array in half, making a recursive call, and merging the results until it reaches the bottom of the array tree.
For this task, we are going to draw 8 cards from the top of the deck. So the first thing we do is we shuffle this deck of cards and we randomly choose 8 cards on top of the deck. We then see this as an array with their respective values as numeric elements. As per the saying, divide and conquer, we first divide the array into 2 subarrays, the right and left partition respectively. We now see this as 2 subproblems that we have to solve. Divide and conquer recursively solves subproblems. Each subproblem must be smaller than the original problem, and each must have a base case. Divide and conquer algorithm has 3 parts. So we divide up the problem into a lot of smaller pieces of the same problem. So divide. We now then conquer the subproblems by recursively solving them. So we solve the subproblems as base cases if they're small enough. And to find the solutions to the original problem, we combine the solutions of the subproblems. And now we have completely sorted this deck of cards using the merge sort algorithm. Thank you.
Why is merge sort considered a useful sorting algorithm, and what are some of its standout advantages and practical applications in the world of computer science?
That's a good question. One thing you might be curious about is the algorithm's area of expertise. So, why do we need this algorithm when there are already so many sorting algorithms? Well, merge sort has a temporal complexity of O(n) log n, which enables it to sort big arrays quite quickly. This is one of its key advantages. The order of elements with equal values is maintained during the sort because it is a stable sort. Merge sort is a pretty interesting algorithm and a very basic example of how to approach divide and conquer algorithms. But to the contrary, being a very basic algorithm, it has a really vast application domain.
How does merge sort compare to other sorting algorithms like quicksort or bubble sort?
Merge sort is more consistent and reliable than quicksort, which has a worst-case time complexity of O(n squared). Merge sort also outperforms bubble sort and similar quadratic time algorithms for large datasets. Merge sort is preferred in scenarios where stability, consistent performance, and sorting large datasets efficiently are important requirements.
This Java program executes a sorting algorithm called merge sort, which splits an array in half, sort each half separately, and then combines the sorted halves into a single array. An array is initialized, sorted using merge sort, then printed in the main function. A utility function to print arrays is also available. As a result of its foundation in the divide and conquer principle, merge sort is a potent sorting algorithm that is trustworthy and effective for organizing huge datasets while preserving stability in the order of equal components. With an O(n log n time complexity, it is a good fit for many practical computer science applications. Even if there are various sorting algorithms, merge sort stands out due to its reliable performance and flexibility to adapt to a variety of domains.